Hello, we are going to start multiplying monomials in our unit on polynomials. And I'm going to give just these 4 examples just to kind of smooth our entry into the whole process of multiplication, because I have a feeling we are a little bit unclear on what multiplication exactly is. So the first thing I'm going to do is teach what multiplication is, and then we'll get into how that applies to polynomials, and then we'll end up doing review on laws of exponents. Okay, so the first things first. Let's figure out what in the world is multiplication, right? So we got to start with some vocab. So we figure out first, well, what in the world is multiplication? Multiplication could be one of 2 major things that I made up. The first is grouping equal amounts. Okay, so that's the first definition of multiplication, grouping equal amounts. And here's how that works. If we were to add 3 plus 3 plus 3 plus 3 plus 3, we know that's going to be 15. And so we figure what just happened. We grouped the same amounts 5 different times. So we have 5 groups of 3. And then 5 groups of 3, of course, is 3, 5 times, also known as 5 times 3. And so we know that's 15. Okay, so we know 5 times 3 is 15. We know the same thing works for 3 groups of 5. We know it's 15. So multiplication is basically a process of grouping equal amounts. And that's what we've known for multiplication for a very long time. That's how we've applied it. That's why the commutative property works. So all sorts of things about that definition of multiplication. Multiplication is something else as well. Multiplication is also expanding dimensions. And we talked about this before when we talked about like terms and defining what is a term. Okay, so we talked about dimensions when we talked about what is a term. The cool thing with expanding dimensions is that you know what we're allowed to do? We can multiply units. Okay, and that's going to come back in a second. I'll give you an example of what I'm talking about. Let's say, for example, that we had some length, right, one dimension, a length of 7 inches, and we want to add to that another length of 38 inches. Is that going to expand the dimension? No, we're still working in only one dimension. And so what we can do in that one dimension is simply combine the 2 lengths, and we get 45 inches. Okay, so if we just combine those 2 lengths, we have 45 inches, and we need to remember that we can add only if the units are the same. Okay, so it goes back to the term. So this is addition, but we're going to now investigate the difference between that and multiplication. So now the question is, what if we took the same 2 lengths, right, a 7 inches and a 38 inches, but instead of saying in the same dimension of length, we want it to expand that thing, right? We want it to expand those dimensions. We're going to, instead of going in one dimension, we're going to see now about 2 dimensions, and that is what area is. Okay, so now what we've done is that instead of taking our 7 plus 38 in one dimension, we're going to see what's going to happen with 7 and 38 in 2 dimensions. And that now involves area. And how do we calculate area? Well, we multiply 7 inches by 38 inches. And that's how we would say, 7 by 38. Or we add 7 inches times 38 inches. We have 266 inches squared now. Now we have this whole other concept, this whole new dimension of square inches, which goes back to that note that I had talked about before. We can actually multiply the units, because inches times inches, inches times inches, inches times inches is square inches. So is it possible then to work in 2 separate units altogether and multiply them? And the answer is yes. So here, let's take this pretty cool example. I drew a little picture. Let's say we had a 100-pound weight. So this weight takes, it's 100 pounds, and we wanted to lift it 3 feet in the air. What type of force does this little guy here have? What type of force is he going to need to lift that 100 pounds 3 feet vertically in the air? We can multiply those two. We can also multiply the units. We can multiply feet times pounds and get this whole other unit called foot-pounds. And this is a thing that exists. It's a measure of force. Okay, so we have 100 pounds. What force is required to lift 100 pounds 3 feet vertically in the air? 300 foot-pounds. That's something that exists. And an FYI, I figured if I'm going to show you foot-pounds, might as well show you this. Did you know, now that we know what a foot-pound is, 550 foot-pounds of force, right? If we lift 550 pounds 1 foot vertically, and we do that in 1 second, if we lifted 550 pounds 1 foot vertically in only 1 second, we have demonstrated the power of 1 horse, or 1 horsepower, or so we say. I've never seen a horse lift 550 pounds in 1 second, but we come to that. So now for all you motorheads out there, now you know what a horsepower is. It's lifting 550 pounds vertically 1 foot in 1 second. So we have force, and then power involves time. Force does not. So actually power is a whole other thing. If you notice, there's a third dimension there, time. Anyway, but that's not the point. The point is we're teaching multiplication. So we know multiplication, not only is it grouping equal amounts, it is expanding dimensions. And so why is it then that you always wondered, can we multiply x times y? Yes, we can, because we can also multiply pounds times feet and even times time, and then we can get these new units that do exist. Okay, so multiplication is a whole different monster than addition, as demonstrated by here. So hopefully that helps explain some of the things that are going on in these expressions. Because remember, we can multiply anything, and we can multiply units. Okay, we'll just create new units. So I'll get into distributive property here. I'll talk more into detail about what's going on with number 3 and number 4 in the next lesson. But for now, just know that we can multiply stuff all out. So in number 1, it's pretty simple. We're just using the laws of exponents, right? So at number 1, all we are doing is real simply multiplying 3 times x to the 4th times 2 times x times negative 2 times y, and we can multiply all those things, and we can multiply units. In case we can multiply 3 times 2 times negative 2, or we would get negative 12. And then we can multiply x to the 4th times x times y, and now we have some review from laws of exponents. If you remember the review from laws of exponents, any base times the same base, we just simply keep the base and add the exponents. Okay, so what's going on with the x's is exactly that law. So we have negative 12, x to the 5th power y. And can we do that? Yes, we can, because we can multiply units. It is a thing that exists. Okay, so we've just multiplied those units. And that's as simple as number 1 can get. Number 2 is very the same thing. It's just the same thing. We're multiplying 5m to the 4th power n p to the 3rd power times negative 8 m n p to the 5th power. So we can multiply the things that we can multiply, and we multiply the units as well. And so we have negative 5 times negative 8, m to the 4th power times m, n times n, and then p to the 3rd power times p to the 5th power, and we just exercise that law of exponents. Okay, so it's very similar to what we have previously worked on. So negative 5 times negative 8, of course, is positive 40. M to the 4th times m is m to the 5th. N times n is n squared. And then p to the 3rd, p to the 5th is p to the 8th power. Okay, so we have that simplified expression. All right, so we're multiplying. It's just we're either grouping or expanding dimensions. So that's what we've done here, expanding dimensions. Now we get into number 3. And for this video, I'm just going to talk about the distributive property. And so remember how the distributive property works. The distributive property is when we can multiply through a group. Okay, so that's what the distributive property is. We're multiplying a group, so we can multiply through a group. Okay, so this is multiplying a group means we can multiply through the group. All right, so we're going to see the group and then multiply through it. And so what we would have on our hands then is negative 5a squared times 3a squared. Then we would have negative 5a squared times, that's a negative 6a. And then we would have negative 5a squared times a positive 5. Okay, so we can simply multiply through the group. Okay, so if we're multiplying a group, we can multiply through the group. And then I'm just demonstrating the, the distributive property. So now we can just start multiplying our stuff out, right? Negative 5 times 3 is negative 15. A squared times a squared, a to the fourth. Negative 5 times negative 6 is 30, positive, and then a to the third. And we did say positive, right? So positive. And then negative 5 times 5 is negative 25, a squared. Okay, so remember, for multiplying, we can multiply units. We can expand our dimensions. For adding, we cannot. We can only add if we have the same units. None of these units are the same. So we are done. This is our simplified expression. So we're looking at things in terms of units of measure. Hooray, science! Right? And so that's how that would work. And it's the same thing with, of course, the last one, number 4, as well. And so we can multiply the exact same way. So we're multiplying a group. That means we can multiply through the group. Okay, so we can multiply through the group. If we're multiplying a group, multiply through the group. All right, so we have 2xy times negative 3x squared y. Then we have 2xy times 4xy. And then we have 2xy times negative xy squared. And remember, multiplication can work across units as well. All we're doing is expanding dimensions. And so we can multiply units. So therefore, we have 2 times negative 3, negative 6. X times x squared is x to the third power, and y times y is y squared. And now we have 2 times 4, which is 8. X times x is x squared. Y times y is y squared. And then 2 times negative 1. We can look at it as 2 times negative 1 is negative 2. And then x times x is x squared. Y times y squared is y to the third power. And we look at that 8. We need that sign there, right? That's a positive 8. And so we can put the plus sign there. Our multiplication is done. Now we're looking at addition, and so we have to look for the same units of measure, and clearly there are none. So this is our simplified expression. So negative 6x to the third y squared plus 8x squared y squared, and then minus 2x squared y to the third. And that is our simplified expression. So in the next lesson, we're going to get into how do we multiply polynomials, and then we'll start talking more about area. Okay, but hopefully you learned what is multiplication and how that applies with laws of exponents. Thank you much. Stay tuned for more.